Last week, we saw the equation V is equal to delta D over delta T. We've since started calling that our group A equation because it involves acceleration. If I wanted to solve for displacement, what would I do? If I want to get displacement by itself, then I would get rid of the time, right? Because time is attached to the displacement. It's divided by time, so I would get rid of it by multiplying. D is equal to V times T. Now, if I wanted to solve for time, I would do exactly what I just did, get time on the top, right? You want to solve for something, you got to get it on the top and then get it by itself. So I would get it on the top like I just did, and then I would turn around and T is multiplied by V. So in order to get rid of the V, I would do the exact opposite, right? I would divide. So I would say T is equal to delta D over V. Okay, we know how to rearrange this one, right? We spent quite a bit of time using this equation last week, and I think we're pretty good at that. But what if we got a new equation, like one of the ones that we learned today, for instance, D is equal to VIT plus 1/2 AT squared. This is one of our group B equations. One of our 5 group B equations that are valid whenever we have acceleration. I'm going to rearrange this to solve for, let's say I want to solve for VI. Okay, listen carefully. What you want to do is get the variable that you're solving for on the top by itself. It's already on the top, right? We're not saying like T up here that it's on the bottom. Okay, VI is already up top. It's not on the bottom underneath anything. So we don't have to worry about that. So now we just got to get it by itself. Well, how do we get it by itself? You got to get rid of, listen carefully, what's not attached, and then get rid of what is attached. Okay, tell me the variables that are not attached to VI. Tell me what variables are not connected or not touching VI here. Yep. Acceleration, P squared. That whole term, 1/2 AT squared, is not connected to it, right? The T here is connected to it or is attached to it. Get rid of what's not attached to VI. Got it? Now, what's not attached to VI? 1/2 AT squared. It's added to VI, right? If it's multiplied or divided, it's attached. If it's added or subtracted, it's not attached. All right, if it's added, how are we going to get rid of it? Subtract it. So we're going to say delta D minus 1/2 AT squared. Let's just get rid of the whole term at once. What's not attached to VI. Did that make sense what I just did there? When I had V is equal to delta D over delta T, if I want to get rid of T, I did the exact opposite. We divided D by T, so I multiplied by T to get rid of it. If I'm adding 1/2 AT squared, and I want to get rid of 1/2 AT squared, I'm going to take it to the other side by subtracting. All right, now I got to get rid of what is attached. What is attached to the VI? Delta T. So how do you get rid of it? Divide it. So we're going to say that D minus 1/2 AT squared divided by VI equals delta T. Now, sorry, what am I solving for? Not delta T. Solving, we're going to divide by T to get VI there. Does that make sense? That's a pretty ugly looking equation right now, right? D minus 1/2 AT squared divided by T equals VI. Hey, it's right. Get what you're looking for on the top and then get it by itself. VI was already on the top, so I got to get it by itself. How do I get it by itself? Get rid of what's not attached by doing the opposite, and then get rid of what is attached by doing the opposite. Okay, let's take the same equation and let's solve for A this time. Okay, let's solve for A instead. D is equal to VIT plus 1/2 AT squared. Is A on the top already? Yes. Don't have to worry about that. Is it by itself? No, delta D is the only thing by itself. So if I want to solve for A, get it by itself, I got to get rid of a bunch of things. Tell me what is not attached to A. What's not multiplied or divided by A, Ryan? It looks like your hand is about to go up there. VI and T, okay? VI and T are added to 1/2 AT squared, so I'm going to take them over by subtracting. So we're going to say D minus VIT equals 1/2 AT squared. And remember, we're still solving for A here. Okay, I got rid of what wasn't attached. Now let's get rid of what? Get rid of what is attached. What's attached to the A? The half and the T squared, right? We can take them over one by one, or probably makes sense, just take them over together. We're going to say D minus VIT over 1/2 T squared. 1/2 times T squared is multiplied by A, so let's take it over by dividing. Equals acceleration. Make sense? Okay, let's take a look at another one. Another example here. D is equal to VI plus VF over 2 times T. Want to solve for T. Is T by itself here? Is T on the top, first of all? Yes. Is it by itself? No. What's not attached to T? Everything's attached to it, right? Because we got brackets here. Because there's brackets, everything is attached to T. So we don't have to worry about that. Okay, let's get rid of what is attached. VI plus VF over 2 is attached to T. We've multiplied VI plus VF over 2 by T. So how do we get rid of it? We divide. So we're going to say delta T is equal to delta D divided by, and this looks kind of ugly, but it's correct. We multiplied that whole term by T. So now, to get rid of it, we're going to divide that whole term by T. Let's say VF squared is equal to VI squared plus 2AD. Let's solve for A here. Is it on the top? Yep. Don't have to worry about that. Let's get rid of what's not attached to it. What's not attached to the A? What's not attached to the A, Blake? VI squared. How is it not attached? Like how is it? It's added on. So we're going to take it over by subtracting. Not because this is added here, but because it's plus VI squared as opposed to minus VI squared. So we're going to take it over by subtracting. VF squared minus VI squared equals 2AD. What is attached to the A? What is it? I heard somebody say part of it, 2. Is there anything else that's attached to it? Displacement. We might as well take them over together. You could take them over separately, but you might as well do it together. VF squared minus VI squared over 2 times D equals A. Good? Okay, one more. One more that goes a step further here, okay? VF squared equals VI squared plus 2AD. Want to solve for VI. Want to solve for VI. Is it on the top? Yeah, good. Is it by itself? Nope. VF is almost by itself, although there's a square there. Okay, let's get rid of what's not attached. What's not attached to the VI? What's not attached to the VI here? There we go. Good, plus 2A delta D. Okay, how do you get rid of a plus 2A delta D? Subtract it. So let's say VF squared minus 2AD. Just take the whole thing over at once. It's one term. Take it over by subtracting. Equals VI squared. Now, VI is pretty much by itself now, but it is squared. We haven't talked about this yet. Okay. The rule is get it to the top. Okay, all the ones we've dealt with have been on the top already. Then get it by itself. How do you get it by itself? Get rid of what's not attached, then get rid of what is attached. But if you have a square or a square root, you got to get rid of that as well after you've done everything else. And how do you do that, Erica? Good. Good. You're going to square root it. So VF squared minus 2A delta D. Oops. Square root equals VI. So when you're dealing with a square or a square root, you got to do the opposite, but do it at the end. Do it after you've got rid of what's not attached and after you've got rid of what is attached. Does that make some sense?